All right, folks, we are back to do 5-8. In 5-7, remember we did law of sines and we were solving triangles. Now we're going to solve triangles with law of cosines. So I'm going to jump right into it. Let's get to my notebook. We got law of cosines. And the actual law of cosines is where I'm going to start. When we want law of cosines, or LOC, we could have a few different versions. You could have a squared equals b squared plus c squared minus 2bc cosine of a. Now, if you remember this, what you're going to see is I have a over here and a over here. In between, I use b and c. All right, same idea for the other version. If I have b squared here, I'm going to have a squared and c squared here, and minus 2ac and cosine of b. Again, the outside matches, the inside stays as the other pieces. So if I have c squared here, I have a squared plus b squared minus 2ab cosine of c. So this is a little more involved, but there are times we need this. And those times we need this is what I'm going to start talking about. Just like we did with the others, we knew law of sines we used when we were given two angles and a side, or two sides and the non-included angle. Now we're going to look at the first case we would use law of cosines to solve a triangle is when we're given two sides and the included angle. So the included angle here is the difference between this and the law of sines version. Now, what does that mean? Well, let's look at an example. I think that's the easiest way to dive into this, is if they ask you to solve the triangle. And they give you this. Let's see, they give you A is 10, side A is 10, side C is 8, and angle B is 100 degrees. Now, again, if we just sketch out a quick triangle where I've got A, B, and C, and where this is A, this is C, and this is B, they gave us A, they gave us C, and they gave us angle B. You can see this is the included angle for two different reasons. One, if you drew it, you could see that it's the angle created by the two sides. The other thing that makes this obvious is, remember when we had the non-included angle, we had a pair in here. We had an angle that matched a side in terms of their letter. So now we don't. Now we've got three separate letters. And when you have two sides and an angle and they're all three separate letters, that's what you have, is the two sides and included angle. All right. So it's what we have. Now, when you look at this, though, if I could find side B, then I would have a pair. So if I do this carefully, I can use law of sines the rest of the way. So I'm going to find side B. I'm going to find side B by using this version. B squared equals A squared plus C squared minus 2AC cosine of 100 degree, or cosine of B. Sorry, I was doing it all in the one form. We'll continue in that form. So cosine B. So now let's plug in what we know. B squared equals A squared is 10 squared, so that's 100. C squared is 64, that's 8 squared, minus 2 times A, which is 10, times C, which is 8, times the cosine of 100 degrees. Now, when I put this in the calculator, again, just being paranoid because I want to make sure I do this properly and not having to worry about the right syntax in the calculator, I start generally, well, first we're going to be doing a cosine, so I'm going to check that I'm in degree mode. And once I have that, I'm going to do cosine of 100 degrees and hit enter. Now I've got a value there. Now if I just hit times, I can multiply it by each of the things that we see multiplying here, the 8, the 10, and the -2. I'll consider that a -2. So I can do answer times 8 times 10 times -2, and I hit enter again. And now I am going to add 164 and then take the square root of that. And I get that, let's see, b squared. Let's write this down so you can see what I got. B squared equals 191.837.084. And I took the square root of it to find b. And to the nearest tenth, that would be 13.8. But when I'm working with this, well, let's just do that. All right, so that is 13.8. So we've got 13.8 there. That is our side. Now we've got a side and an angle. So now I can solve for, I need the other two angles, right? I need angle A and angle B still. So I can find those using my pair that I have. I have a pair that is 13.8. Now this is risky because like I always preach to you, we want to use givens if we can, but the if we can is the key there. We can't here. So we're going to use this to do what we have here. And I'm going to go after A. So I want A is 10. I want sine A, and I'll find angle A. All right, so I know sine A equals 10 sine 100. Again, I might have glossed over that quickly. I'm using law of sines now because, again, it's quicker and easier than law of cosines. And it's the most appropriate to use after this to finish this up. So we can find law of sines, we can find angle A here. And so angle A is going to be equal to sine inverse of this whole thing, 10 sine 100 degrees over 13.8. And that makes angle A equal to 45.5 degrees. And now we've got our second piece. We have one more piece. Remember, they give us three pieces in unknown triangles, and we have to find the three other pieces. We have one last thing, and that's angle C. But how can we find angle C? Angle C is going to be what's left of 180. Again, no need to use anything fancy here. Angle C will just be 180 degrees minus that 100 degrees we started with, plus the 45.5 degrees we found. And that would give us, what does that end up being? 34.5 degrees. So we've got our third piece, and we've used law of cosines. So we can use this, again, just to go back and look at it. We knew we had two sides and the included angle, we need the other side. That side that matches this angle we can find using law of cosines, whichever version is appropriate. If we need A, we use that. B, we use that. C, we use that, right? So that's two sides and the included angle. So two sides and the included angle, when we have this, the process is going to be find the side using law of cosines, then find the first angle using law of sines, and then use 180 minus to find the second angle. All right, so that's a three-step process there. And perhaps we should write that down. We've got time to do that. So 3 steps for two sides and included. For two sides and the included, first step is to find third side using law of cosines. Second step is to find an angle, I'll say, depending whichever one you wanted, using law of sines. And then third, find remaining angle, or last angle, whichever way you want to think of it. And you're going to do 180 minus, 180 degrees minus whatever you had. All right, so that's what we do for that. So there's one other time we use law of cosines I want to go over. And that is when we're given 3 sides. Now, when we're given 3 sides, this is the other way we do it. This form is not as useful. All right. When we're solving for, obviously we have to start by solving for an angle. What we would do here is solve for cosine A. So I would do A squared minus B squared minus C squared, right? Subtracting both of these. And then divide by a negative 2BC, and that would give me cosine A. And once I have cosine A, I can take cosine inverse. So I could find A here by doing cosine inverse of A squared minus B squared minus C squared over a negative 2BC. So what do you think I would do if I wanted to find angle B? Well, angle B would be equal to cosine inverse of, and then what are we going to start with? We're going to start with B squared now, minus A squared minus C squared over a negative 2AC, right? And finally, I can do angle B, or angle C, sorry. What I was thinking there. All right, angle C would be equal to cosine inverse of C squared minus A squared minus B squared over a negative 2AB. And we have everything we need. And you don't have to memorize these, honestly. If you memorize the original one, this up here, you can just solve for it. Subtract each of these quantities, then divide by what's multiplying cosine A, and just go backwards. All right, so let's do an example. An example would be something like this. If I gave you that A equals 20, B equals 12, and C equals 28, and said solve the triangle. Well, now I can start wherever I want. What I would suggest doing, and you'll see this come up in homework as to why, I would start with the largest angle, which is always going to be opposite the largest side. So I always start there. And it's just something I found to not allow us to make mistakes later. And we'll go into that in class into more detail, why that's a good idea, but I would always suggest it. So I'm going to start with my law of cosines because I was given 3 sides. Same as I did before. I'm going to find law of cosines. I'm going to use that to find an angle. So I'm going to find angle C. So angle C will be cosine inverse of 20, or A squared. I'm sorry. Got myself all flustered there. C squared minus A squared minus B squared over a negative 2AB. And for us, that means cosine inverse of 28 squared minus 20 squared minus 12 squared, all over negative 2 times 20 times 12. All right, so again, I'm going to start inside the fraction, and I'm going to start with that numerator at 28 squared minus 20 squared minus 12 squared. And we take that and divide it by a negative 2 times 20 times 12. And then I want cosine inverse of that. So I do second cosine of the answer. And I should get that angle C. This is angle C. Angle C equals 120 degrees. So angle C is 120. All right. Now, I've got what? I've got angle C here. So what does that give me right now? I had these 3 pieces, but I already have C. So now I can do a pair. I can use law of sines for the next one. Same process we did last time. Now I can switch over to law of sines, right? And law of sines, I know that I've got 28 over sine 120 degrees should equal, and I'll go to the next one, A is 20 over sine A. So when we do that, we get sine A equals 20 sine 120 degrees divided by 28, which makes angle A equal to sine inverse of this quantity. So when we do that, we plug in sine inverse. I'm sorry, first let's start with 20 sine 120 degrees. Divide that by 28. Take sine inverse, and angle A should equal 38.2 degrees. So now we have two angles, right? We had 120 degrees, we had 38.2 degrees. So now we can find our third angle, which is angle B, and that'll equal 180 degrees minus our other two, 120 degrees plus 38.2 degrees. And when we do that, we get angle B is equal to 21.8 degrees. And we have our triangle solved. All right, so that is what we're doing. Our next lesson will be on the areas of triangles that, again, we don't know anything else about. So those are just your general triangles and how to find areas. But you have an assignment for this, and we'll go over it tomorrow. Have a wonderful day, folks, and I will see you next time.